In 1932, Ford built an engine that changed everything. The Flathead Era put affordable power in the hands of ordinary Americans for the first time. It launched hot rod culture, democratized performance, and became a legend. But it was also a disaster. Chronic overheating, constant breakdowns, and design flaws that drove mechanics crazy for decades. Today, we're uncovering the full story of the Ford Flathead Era, the engine that was both revolutionary and deeply fundamentally broken. Before we understand why Ford's Flathead was revolutionary, we need to step back into the automotive landscape of the early 1930s. V8 engines weren't new, they'd been around since 1904, but they were the exclusive domain of luxury manufacturers. Cadillac had perfected the V8 for their premium lineup, Packard built magnificent straight-eights, and companies like Lincoln crafted hand-assembled V8s that cost more than most people's houses. The reality was stark. If you wanted 8 cylinders of American power, you needed serious money. These engines were engineering marvels, sure, but they were also engineering nightmares to manufacture. Each V8 required precise machining, hand-fitting, and assembly techniques that made them prohibitively expensive. We're talking about engines that added $500 to $800 to a car's price, when the average Ford Model A cost just $385. Most Americans were driving 4-cylinder engines, maybe a straight 6 if they were doing well. The performance gap was enormous. A typical 4-cylinder produced maybe 40 horsepower on a good day, while those luxury V8s were pumping out 90, 100, even 120 horsepower. But that power was locked behind a financial wall that kept it away from ordinary drivers, mechanics, and the growing community of speed enthusiasts who were just beginning to modify their cars for performance. This is the world Henry Ford was looking at in 1930. Segment 2. Ford's Risky Leap. A world where 8-cylinder performance was rationed by price, where the technology existed but remained trapped in the hands of the wealthy. Ford saw an opportunity not just to build another car, but to democratize power itself. Henry Ford's decision to develop a mass-market V8 was audacious to the point of seeming reckless. While his competitors were focused on refining their expensive, hand-built V8s, Ford was asking his engineers to solve an impossible puzzle. How do you build a V8 engine that can be manufactured on an assembly line, sold at a price regular people can afford, and still deliver the performance that makes 8 cylinders worthwhile? The solution they developed was brilliantly simple and fatally flawed at the same time. Instead of the complex separate cylinder construction used by luxury manufacturers, Ford's team designed what became known as the Flathead configuration. The entire engine block, cylinders, crankcase, everything, would be cast as a single piece of iron. The valves would sit beside the cylinders in the block itself, operated by a simple camshaft with the combustion chambers formed by flat-topped pistons moving in cylindrical bores. This design eliminated hundreds of precision machine parts, dozens of assembly steps, and the need for skilled hand-fitting that made other V8s so expensive. Ford could literally pour molten iron into a mold and create most of the engine in one piece. It was manufacturing genius. Henry Ford's assembly line philosophy applied to the most complex engine of its time. But here's where the problem started brewing, even before the first engine fired up. That flathead design created inherent airflow restrictions. The exhaust gases had to make sharp turns to exit the combustion chamber, creating turbulence and heat retention. The cooling passages were compromised by the need to cast everything in one piece. What Ford gained in manufacturing simplicity, they were about to pay for in thermal management nightmares. None of this mattered to Henry Ford. He'd set an impossible deadline. The engine had to be ready for the 1932 model year, giving his team less than 2 years to design, test, and perfect a completely new V8 architecture. Segment 3, Mass Production Miracle. When the Ford Flathead Era debuted in March of 1932, It didn't just change the automotive industry, it shattered it. Ford had achieved the impossible, a genuine V8 engine in a car that cost just $460, barely more than their four-cylinder Model B. Overnight, they'd made eight-cylinder performance accessible to middle-class America. The manufacturing breakthrough was the cast iron block technology. While competitors were still bolting together separate cylinders, machining individual components, and hand-assembling their V8s, Ford was casting entire engine blocks in massive foundries. The River Rouge plant became a temple of mass production, with enormous furnaces melting iron around the clock and precision molds creating thousands of identical engine blocks every day. But the real innovation wasn't just the casting, it was the entire production philosophy. Ford standardized every possible component. The crankshaft, connecting rods, pistons, even the valve springs were designed for high-volume manufacturing. Where a Cadillac V8 might have dozens of unique parts requiring individual attention, the Flathead used identical components wherever possible. Left and right cylinder heads were the same part, just flipped. The intake manifold was a simple casting that could be machined quickly and cheaply. This approach allowed Ford to achieve economies of scale that their competitors couldn't touch. By 1934, they were producing over 400,000 Flathead 5.8s annually. More V8s engines than the rest of the industry combined had built in the previous decade. The price continued to drop as production ramped up, making V8 power not just affordable, but almost commonplace. The market response was immediate and dramatic. Ford's sales jumped 50% in the Flathead's first year. More importantly, they'd created something entirely new. For the first time in automotive history, a factory worker could afford the same basic engine architecture that powered luxury cars. Segment 4, the Flathead Era. The Ford Flathead 5.8 didn't just put affordable power in driveways across America. It created an entire culture. Within months of its release, young mechanics and speed enthusiasts discovered something remarkable. This mass-produced engine responded beautifully to modification. Unlike the precious, hand-built V8s in luxury cars, the Flathead was robust, simple, and almost infinitely tunable. The engine's fundamental architecture was perfect for hot rodding. That simple valve and block design meant fewer moving parts to break under stress. The cast iron construction could handle significant power increases. Most importantly, the engine was everywhere. Crashed cars, junkyards, and Ford dealers provided an endless supply of affordable Flathead cores for builders to work with. By the late 1930s, the dry lakes of Southern California were echoing with the sound of modified Flatheads. Guys like Ack Miller and the early hot rod pioneers discovered they could coax incredible power from these engines with basic modifications. Boring out the cylinders, installing multiple carburetors, advancing the timing, and opening up the exhaust. A stock Flathead made 65 horsepower. A well-built hot rod motor could push 150 horsepower or more. The Flathead became the foundation of American hot rod culture because it democratized not just transportation, but transformation. A teenager could buy a crashed 32 Ford for $25, pull the engine, and with basic tools and some ingenuity, build something that could outrun cars costing 10 times as much. The engine's simplicity made it accessible to backyard mechanics who learned by doing, not by reading expensive service manuals. Racing sanctioning bodies took notice too. The Flathead became the standard engine for numerous racing classes, from circle track to drag racing. Its combination of power, reliability, and affordability made it the perfect competition engine for grassroots motorsports. By 1940, if you were serious about going fast on a budget, you were probably building a Flathead. This cultural impact cannot be overstated. The Flathead Era 5.8 created the template for American performance culture that persists today. Take a mass-produced engine, modify it cleverly, and go fast without breaking the bank. Segment 5, the cracks begin to show. But here's where our story takes a darker turn. The same design compromises that made the Flathead affordable and mass-producible also created fundamental problems that would plague the engine throughout its production life. The most serious issue was heat, specifically the engine's complete inability to manage it effectively. Remember that cast iron block design that made mass production possible? It created a thermal nightmare. The exhaust ports were buried deep inside the block, surrounded by cooling passages that were too small and poorly positioned. Exhaust gases had to make tortuous turns to exit the combustion chambers, creating hot spots that the cooling system simply couldn't handle. The valve seats, located right next to the cylinders, absorbed tremendous heat with nowhere for it to go. The result was predictable: chronic overheating, warped cylinder heads, burned valves, and cooling system failures. A well-maintained Flathead might run reliably at moderate speeds, but push it hard, climbing mountains, towing loads, or sustained high-speed driving, and you were almost guaranteed problems. Service stations across America became intimately familiar with Flathead cooling system repairs. The engine that had democratized V8 power was also teaching America's mechanics hard lessons about thermal management, or the lack thereof. But perhaps no single incident illustrated the Flathead's thermal disasters more dramatically than what happened during the 1940 Indianapolis 500. 3 Ford-powered race cars entered the event, all running heavily modified Flatheads designed to compete with the specialized racing engines from Miller and Offenhauser. On race day, all 3 cars suffered catastrophic overheating failures within the first 100 miles. One engine literally cracked its block in half from thermal stress, spewing coolant across the track and forcing a caution period. The incident was so spectacular that Indianapolis officials briefly considered banning Flathead-based engines from future races. Hot rodders discovered these limitations quickly. While the Flathead responded well to basic modifications, serious power increases made the heat problems exponentially worse. Racing teams developed elaborate cooling system modifications, exotic lubricants, and careful tuning strategies just to keep their engines from self-destructing. The phrase "it runs hot" became synonymous with Flathead ownership. Ford's engineers knew about these problems from the beginning, but the fundamental architecture couldn't be fixed without abandoning the manufacturing advantages that made the engine viable. They tried various band-aids: improved water pumps, better thermostats, revised cooling passage designs. But the core issue, heat trapped in a block design optimized for manufacturing, not thermal management, remained unsolvable. Segment 6, end of the line. By the late 1940s, the automotive world was changing rapidly, and the Flathead's fundamental limitations were becoming impossible to ignore. General Motors had introduced overhead valve V8 designs that solved the Flathead's thermal problems while delivering significantly more power. Cadillac's new 331 cubic inch V8 was producing 160 horsepower cleanly and reliably, power that required extensive modifications to extract from a Flathead, and even then came with severe reliability compromises. The writing was on the wall. Ford's own engineers had been developing overhead valve designs throughout the 1940s. Knowing that the Flathead's architecture had reached its limits, the engine that had been revolutionary in 1932 was becoming an embarrassing relic by 1950. Competitors were building engines that ran cooler, produced more power, lasted longer, and required less maintenance. Everything the Flathead struggled with. Ford's response came in 1954 with the introduction of their overhead valve Y-block V8. This new engine incorporated everything they'd learned from 2 decades of Flathead production and problems. The combustion chambers were properly designed for airflow, the cooling passages were engineered for thermal efficiency, and the overhead valve design eliminated the heat retention issues that had plagued the Flathead. The transition wasn't immediate. Ford continued producing Flatheads for trucks and industrial applications through 1953, recognizing that some customers valued the engine's simplicity and low cost over its performance limitations. But for passenger cars, the Flathead era ended definitively with the 1953 model year. Interestingly, the Flathead's death in America coincided with its adoption internationally. Ford continued producing Flathead Final 8s in Europe and other markets well into the 1960s, where different driving conditions and performance expectations made the engine's limitations less critical. But in the American market that had created it, the Flathead Era 8 was obsolete, replaced by designs that could deliver everything it had promised, but with the reliability it had never achieved. The irony is profound. The engine that had democratized V8 performance was killed by better democratization. General Motors, Chrysler, and eventually Ford itself proved that overhead valve V8s could be mass-produced just as affordably as flatheads, but with vastly superior performance and reliability. Segment 7 Legacy. So why, 70 years after its replacement, do we still talk about the Ford Flathead Vive 8 with such reverence? Why does an engine famous for overheating and reliability problems hold such a revered place in automotive history? The answer lies not in what the Flathead was, but in what it made possible. The Flathead Vive 8 was the first truly democratic performance engine. It took 8-cylinder power from the exclusive realm of luxury cars and made it accessible to ordinary Americans. The Flathead didn't just change transportation. It created the foundation of American hot rod culture, drag racing, and the entire aftermarket performance industry. Think about it. Every modern LS swap, every turbo build, every garage project that transforms a mundane car into something extraordinary traces its DNA back to those first hot rodders who figured out how to make flatheads fast. The engine taught America that performance wasn't something you had to buy from a factory. It was something you could create with creativity, determination, and mechanical skill. The Flathead's simplicity, which created its thermal problems, also made it an incredible teaching tool. Generations of mechanics learned internal combustion fundamentals on Flathead Vive 8s because you could see everything, understand everything, and fix everything with basic tools. No complex overhead cam systems, no computer-controlled anything, just pistons, valves, and the fundamental principles of making controlled explosions create rotational force. Today's flathead enthusiasts aren't nostalgic about the overheating or the maintenance headaches. They're celebrating an engine that represented possibility. The possibility that regular people could afford V8 power. The possibility that you could take something mass-produced and make it special. The possibility that mechanical knowledge and creativity could overcome engineering limitations. Modern flathead builds often address the original design's thermal problems with electric water pumps, improved cooling systems, and better metallurgy. These engines can be built to run reliably and produce impressive power, proving that the fundamental concept was sound, even if the original execution was compromised by manufacturing constraints. The Ford Flathead Vive 8 changed everything and broke down constantly. It was brilliant and terrible at the same time, and that's why we still love it. Ever worked on one? Let me know in the comments. And if you enjoyed this deep dive into automotive history, hit that like button and subscribe for more stories about the engines that game changer.